Okay, so it's important to know how to calculate the z-score if you're given a confidence level. Even though you know the calculator trick for confidence intervals, it doesn't necessarily require the z-score. It kind of does all that for you, but you still need to know how to find it for other reasons, okay? For other types of problems and for future things that you're going to do. So this is important. The average daily intake, caloric intake for adult men is normally distributed, very important, with an unknown population mean and population standard deviation of 625 calories. So they're giving us population standard deviation. I always like to know if they're given a population standard deviation. This is very important when you're doing confidence intervals, because you need to know whether you're doing confidence intervals with a known population standard deviation or unknown, and that will change whether you use T or Z, okay? But let's see what we do here. A random sample of men from the population provides a sample mean of. So now in a sample of men, their mean was 2125. Use a calculator to find the z-score, and it makes sense that I would find a z-score because the population standard deviation is known. And when the population standard deviation is known, we deal with z-scores. Use a calculator to find the z-score that should be used to calculate a confidence interval with a 90% confidence level. Now, if you ever, there are a couple ways to do this, but if you ever look at the situation, confidence intervals have two, they have a low end and a high end. The 90% is the area in between two values. One z-score is negative, one z-score is positive. Typically, when we're doing the z-score or we're finding the z-score, we use the positive one, because when we do the calculation for a confidence interval and we're finding a margin of error, it takes care of the plus and minus version, because you have the x bar minus and then the x bar plus. So when we're finding this particular z-score, we're going to find the positive version of it, because that's what we use in the formula when we're doing the formula. So calculator trick is not bad. You know the area and you want a value, which means you're going to do inverse norm. So let's go and look over here. So inverse norm can be found. So we're doing second vars. And you're going to scroll down until you find inverse norm. Now your area is 0.9 because it's a 90% confidence level. Your mean is 0, your standard deviation is 1 because we're dealing with z-scores. And I want you to notice that the center is highlighted, okay? The center is highlighted because it is the middle, right? It's between these two values, these two kind of critical values. So it's important that you put center. And we're going to take the positive z-score, and it's very important to determine how to round 4 decimal places. So 1.6449, if I'm taking 4 decimal places, 1.6449. We're taking the positive version because that is what we would use to plug into our formula for a margin of error to find a confidence level, a confidence interval, if we're using the formula. So we take the positive critical value from this interval. It gives me the negative one and it gives me the positive one.